Welcome everyone. Today we are diving deep into one of the most important topics of the energy transition, that is the battery value chain. They have been researching the ecosystem of Chile, Mexico and Brazil, and will help us to make sense about the global picture, what's happening worldwide, and their intuition and context about what does it mean. I am with two leading experts from the International Council on Clean Transportation, Georg Bieker, Supply Chain Center Lead, and also Eyal Li, Battery Research Expert. Georg, Eyal, thank you so much for your time. So to start, Georg, let's start with the big picture. When we look at the goal of electrifying transport, what do you think are the bottlenecks or the problems that are happening right now?
Thank you, Stefano. So there are two ways of looking at this. The first perspective is maybe the global perspective, where we see that there is several times more minerals in the ground than we need for the transition to electric vehicles over the next decades. We also see that there's enough mining capacities being existing and also being announced. And we see that for cell production, there's several times more production capacities than actual demand. We see a bottleneck maybe in the refining, processing, and the anode and cathode production steps, so like the midstream steps in the supply chain. The other perspective to this is the regional perspective. So they are looking at the perspective from the European Union, for instance. And here it's not only about whether there is enough supply capacities globally available. It's also the question if we have access to it. And there it's a question about reliability of supply chains of the minerals, but it's also about creating local production and supply chains in the EU.
That's interesting. Yeah, I think batteries are obviously important and are the core of the electric vehicle, but we have also seen improvements and technology evolution and new challenges over there. Could you please tell us more about it?
Of course. So for the batteries in electric vehicles today, there are two main groups of batteries, one of which are LFP batteries, lithium iron phosphate, and the second is nickel-containing NMC batteries. LFP provides a less expensive, lower energy content alternative, while NMC has higher energy density and is typically in longer range vehicle segments. Those are basically the two main battery technologies in vehicles on the market today. We see that across the board, the high competition of cell producers is leading to improvements in both of these technologies due to novel module and pack designs, different electrolyte and cathode improvements. And across the board, we're seeing improvements in energy storage capacity, durability, and we expect that these will incrementally continue in the future.
Nice that you touch on durability, because Georg, this question is for you. So there are a lot of uncertainty regarding the durability of an electric vehicle battery. Do you think the battery can outlast the vehicle? What is your take over there?
So the tricky point about this question is that we do not have much data on vehicles that were sold 20 years ago. We can see from the lab testing of today's battery technologies that batteries can be expected to last for 3,000 to 5,000 charge-discharge cycles, and this means for a range of maybe 300 kilometers, this is about 1 million kilometers of range for a battery. And when you compare this to the lifetime usage of cars in the EU, for instance, with 240,000 kilometers, this means that the battery would last 4 times longer than a vehicle. We do not have much data yet on how this results from lab testing plays out in real world, but from the data that we have seen, we pretty much see that confirmed. We actually sometimes see even a higher durability than determined in the lab tests. So this means that we expect batteries to last longer than the electric vehicles, and that means that they are likely to be available also for second life applications after being used in the vehicles.
So Eyal, okay, you already told us about the durability of batteries, but also I would like to know a little bit more about manufacturing. So what happens on the lab test? How are they done?
For a battery to be mass produced in a vehicle at a commercial scale, they undergo several different safety tests. So for a battery to be in a vehicle that you could purchase on the market in the first place, they meet very high standards of safety. We see with battery technology improvements and novel battery technologies that safety is improving, and the very rare chance of a fire happening with the battery, for example, is getting even smaller.
That's great, that's great. Now, let's talk about battery circularity. We're close to the Battery Recycling Day worldwide, so it will be interesting to know, to understand what are the possibilities about and the positive aspect about battery circularity.
Mm-hmm. So as Georg said, we expect batteries to outlast their useful lifetime in a vehicle. So it's very likely that a large volume of batteries will become available for second life applications in uses such as stationary energy storage to support grid stability, peak shaving, etc. That being said, eventually these batteries will reach their end of life, and we don't want these batteries to just end up in a dump. Since these batteries contain some hazardous materials and some toxic heavy metals, such as cobalt, if they end up in a dump, they could pose a risk of these materials ending up in the surrounding environment and create a public health risk for workers and communities living nearby. So it's very important that these batteries are collected and properly dealt with at their end of life. This is where a circular battery economy comes in. It is now technologically feasible for batteries to be disassembled and recycled. And not only does this prevent the environmental and public health risks of batteries ending up in a trash dump, this creates an economic opportunity from an industry being created to recycle them, and it creates a source of recycled materials, lithium, nickel, cobalt, etc., that can provide value when they're reused in new products and even new batteries.
That is interesting. I would like to connect that into Chile, that Chile is a mining powerhouse. So do you see any chance that Chile can scale up on the battery value chain of batteries? Do you see feasible that we can actually build cathodes over there?
Yes, so Chile is currently expanding its role in the battery value chain. Chile has the advantage of being a raw material powerhouse. It's home to about a quarter of the world's lithium reserves, and it produces a majority of the world's copper, both of which are integral materials in lithium-ion batteries and in electric vehicles. So Chile is currently in the process of expanding its mining capacities for both these minerals, and a huge opportunity lies in increasing its capacity to process lithium into the different chemicals that are then used as inputs for cathode material production. It's still an open question as to whether Chile can develop a competitive cathode material industry, but we see that there's particularly an opportunity in the government implementing the provisions in the National Lithium Strategy, and if it's able to meet some of these goals outlined in the strategy, it would create vast economic revenue for the country and has the potential to create a lot of jobs in these industries to create the technologies needed globally for carbon neutral economies.
That's nice. I would like to see it happening in Chile, well, in all Latin America. Georg, it would be interesting for us to listen to you and your opinion about what are the main takeaways of the electrification or for the end user. What is important for them to actually have it in mind and to feel safe and comfortable with this transition?
So from our perspective, we work on electric vehicles because we find that they have 4 times lower climate impact than combustion engine cars in the EU. And this is including the battery production, this is including vehicle production, electricity production, all included. And we see that this is only improving going into the future because there's more and more renewable electricity going online. electrification is the main pathway to decarbonize transportation and to meet climate targets. And the good news here is that the global EV transition is proceeding fast. The costs are decreasing a lot. We are expecting that in most major markets, EVs will be cheaper to buy than combustion engine cars already by 2030. The question now to us and to policymakers is how to speed up this transition in order to meet climate targets and meet the targets of the Paris Agreement. And connected to that is how to scale up the battery supply chains fast enough and how to make sure that supply chains are resilient and sustainable.
I would add a point there that we see with recent geopolitical conflict and resulting oil price shocks that vehicle markets where there is a higher share of EV adoption have proven to be more resilient and less dependent on importing oil from certain regions. So not only do EVs provide this huge climate benefit relative to internal combustion engine vehicles, they also offer to consumers, they also offer economic resilience to fluctuating oil prices.
That's great. So thank you so much, both of you, for this conversation. I think it's very insightful, and also I think it will be useful for the future people who see this video. So thank you so much, guys.
Thanks for having us.
Thank you very much.